Yeah, good morning and good afternoon to everyone. Welcome to our language data science tool offered by IIMSE, Empowering People, Enhancing Education. So this is a demo class and myself, Sahil Bali, data professional with the startup, having experience into leading team, and I'm R certified as well as Python certified professional, right? So this is our course, which is R language data science tool. Okay, and we are having two lectures in this demo class. One is data science foundation and second one is um, R language introduction. But before getting into this, I would like to let you know that just we have not only these two lectures with us, but at the end of the course, at the end of this class, I'll give you some very useful resources of our language, which is very helpful to each and every data professional. Either you are a no voice or you are a experienced one, right? Okay, so let's get started. So today in this data science foundation course, we're gonna cover some of the topics like what is data science, right? Um, uh, okay, yeah. So we're gonna cover basically what is data science, which is very important. Before getting into any profession, you should have a very good knowledge of that profession. By knowledge, I means you should have a knowledge of what that person does in his day-to-day life, right? And what are his challenges, what are his weak points. You should have very good knowledge of all those things. So we will cover all those points within this lecture, which is data science foundation, correct? And we start with data science. What is that and what are the different roles in the market, right? So after doing this course, you should have a knowledge of like where and at what role I can apply, which is very important as per me. And we all know this, that by just doing any course, that is not enough, but you should have a knowledge of market as well, right? And after that, we will cover different forms of analytics, right? And then we have a next slide, which is better understanding of data science. So this is just a quote, and but very important, right? So in important, by important I means like how should be the building block of a data scientist or a data analyst, right? How, I mean, definitely there are some factors, like there are some factors you should have a very good knowledge, like maths is something, right? And software engineering is something, and there is third factor, that is business is something. But over these three factors depends upon something, right? And that's something we'll cover in this third slide, third topic, right? Okay, and moving to next, we'll get into detailed knowledge of different forms of data science. So this is nothing but having a depth knowledge of different forms of analytics, right? So this is relating to this. Okay, and then we'll move to a day of a data scientist, or we can say a data science process. So what a data scientist do, right, in particular project, right? So we'll cover all that. And then we have analytical tools used for data science. So in our market, in our current market, we have a lot of different tools uh, by which we can extract very good insights from that particular data. But at the same time, there are some tools which are more useful and more common to industries, right, and market because of their own reasons, correct? Okay, so moving to next topic, we have real world applications. So what all applications are there in terms of data science where we can use this, correct? And then we have different industries using data science where all these data scientist things are using. So there are a lot of different industries, and even there are other industries which are not touching right now data scientist part, but definitely in future they'll touch it, because this is something which is adding skill to your any profession, right? So data science is something which is is someone who is better at statistics than any software engineer and better at software engineering than any statistician,
Shahid.
right? So please, yeah,
Yeah, 3 minutes back, some network issue got. We are unable to hear you. Just now, it is re-established connection. Could you please
okay,
cover that?
okay.
Yeah.
So should I repeat it?
Previous slide from third point.
This slide,
Yeah,
this one?
yeah, this one.
Okay,
Third one complete.
from third point, from third point,
Yeah,
right?
yeah.
Okay, fine. I'll start with third point. Yeah. Okay. So let's start. We were on third point, right? Better understanding of data science. So this is just a quote, right? But this is a building block, right? What I personally feel, because data science is a buzzword in market right now, but it is just a combination of different skills. So if we talk, the major skill is like maths, and then we have software development, right? And the other skill we have is like business, but all these skills are depending upon this factor. So I would like to definitely discuss this factor. What is that? Which is very, very important. Okay. So let's shift to next point, which is getting into detailed knowledge of different forms of data science. Okay, so this is something, getting into detail of this part, different forms of analytics. We'll get into deep what are the different forms and how we can understand it better, and where we can use it in our industry, how to know that which form is can be used, right? So these are all the things which we'll cover in this topic. Okay. And then we have a data science, a day of a data science, right? So I mean, definitely before getting into any profession, we should have a very good knowledge of what all things he or she does as a data scientist in his day-to-day life, right? Or in a particular project, and that we can call as data science process particularly, correct? Okay, and then we have next is analytical tools. What all tools are required to do data science work, right? So there are many tools in the market, but there are some tools which are unique in itself because of their advantages, or you can say pros, right? So we'll discuss this point in very, very detail. Okay, and then we have a real world application. So how we can use this data science in uh, our day-to-day life. All right, so we'll discuss this. Okay, then we have a different industries using data science. So what all industries are using this data science? Okay, so just a comment, like data science is something which is used by many different industries. But at the same time, I would say there are some industries which are not using right now, but in future, believe me, they'll start using it, because this is not a, a all in a different professional, but it's a adding skill, and that can be added to your current role. Maybe you are a product manager, or you are a simple manager, or maybe you're a techie guy, a software developer. Everyone needs these skills, and these skills makes a different, right, in his own way, and we'll discuss what is that. So there are a lot of industries which are using right now, and lot more to go. Correct, very much required skill. And the second last, we have different companies using our language. Okay, so I mean, because of our language is very unique in its own way, and many companies, well-known companies, are using this, which is very helpful. And then we have what is big data and its importance. Okay, so big data is something which is a buzzword in the market right now, and we'll discuss over this, that what is this, how is it different from data science, what is the difference between data science and big data, and again then we'll cover its importance of a big data. Correct. So let's get started, and before starting this, I would say we have a quote, right? So let's have a look over the same. And I feel till now it's very clear. This makes sense, like what all we are covering here. If you have any kind of doubt, you can please let me know, and I'm very happy to help you. Please drop your comment in the chat box, and I'll definitely solve your issue, right? Okay, so let's move forward. Yeah, so here is the quote. This says a data scientist is someone who is better at statistics than any software engineering, and better at software engineering than any statistician. So I feel most of us have gone through this quote before, because this is nothing new. And but again, there are a lot of people who do not know about this. So I would like to know, like, what do you think about this? What do you think about this statement? What does this tells you, right? Okay, so let me tell you, like, here the statement is saying, like, data scientist is someone who is better at statistics than any software engineer, right? So the thing is, there are statisticians who are into core statistics, right? So they should have a very good knowledge of statistics to do their job. But if we talk about the data science, so the person who is at data science, definitely he should have a very good knowledge of statistics, but not that level, that depth of statistics. It should have a that much knowledge, which is, better than any software engineer. So you can have an idea about that, that it is not required very depth knowledge, but a good knowledge is definitely required. And at the same time, if we'll talk about the second part of the statement, which is which is software engineering, the and better at, software engineering than any statistician. So again, we are having software engineers who are doing the core work, like programming and a lot of different stuffs. But if we talk about data scientists, so again, a data scientist is a person who's definitely having a good knowledge of software engineering, but not that much depth of software engineering. Just a knowledge, very good knowledge is required. Correct. And we will discuss this part in detail in our coming slides. So not to worry, just to make a sense out of this thing, like how much statistics is required and how much software engineering is required in data science work. And definitely we will will dig deep into this, that what all particular skills are required in software engineering, what it all requires in statistics, right? So, okay, making sense, I feel, yeah. Okay, okay, so let's move on. Yeah, so here comes what is data scientist, right? And what are the different roles? So let's cover the first thing, what is data scientist, right? Okay, so before getting into what is data scientist particularly, let's have a look over this diagram and make a sense out of it, like what is this diagram is saying to you. So this is saying like we are having three different skills. One is mathematics, second is business, third is information system. So information system is nothing but software engineering, correct? And let's see where data science stands. Data scientist is in just the middle of all three skills, right? And let's start with the this type, right? So here it says statistical programmer. So what is statistical programmer? The one who is having very good knowledge of statistics, and that can be applied using programs. So that is called statistical programmer. But this statistical programmer should have a knowledge of um, mathematics as well as information system, right? Which is called software engineering. So if you have a knowledge of maths and software engineering, so you can apply this and become a software statistical programmer, correct? Okay, now we'll see what is BI and data scientist. So data scientist or business intelligence developer is someone who's having good knowledge of business and software engineering, that is called information system, right? So having a knowledge of business and those problems can be solved by software engineering, so that is particularly called business intelligence developer or data scientist, correct? And now we have a third different role, which is actuaries. I don't know you have heard this name before or not. So actuaries is someone who's having a good knowledge of maths as well as business, right? So they solve their problem, definitely a business problem, using core maths. So they should have a very good understanding of maths to solve their problem, right? Okay. And now if you have analyzed the diagram given, so you must have seen this, that where is data scientist? So data scientist is in just the middle of everything, right? So what it means is the person who is working as a data scientist, that person should have a very good knowledge. I mean, a very good, I mean, do not get horrified, because what I have seen is most of the time people get horrified. Oh, it requires a lot of different skills. So how will I master this, or how will I get into it, right? So just cover step by step and you will be at your, target. So bull's eye. So that is not an issue, but having all the knowledge, that is very much required, believe me. Okay. So data scientist is someone having maths, business, as well as software engineering knowledge. All three knowledge are very much required. So that becomes a data scientist. Okay. Okay. So except this, I would like to include few more things within this slide, and those are uh, so data scientists require definitely these three skills. But above that, one very crucial skill is, I'll write it down, is storytelling, right? Because this is something which is, so sorry, I do not have pad with me to write it down. Right, so I'm just writing it down. Okay. Yeah. Yeah. So this is a skill which is required very much, right? Because having a problem with you and solving that problem using some what you call statistical modeling or machine learning algorithms, that is a different thing. And getting those knowledge to explain to your CEO, right? Because you have to solve the problem and also explain to them, to your CEO or to your client, right? Because at the end stages, you have to convey your message to either CEO or your client, right? Any of them or any other one, okay? That is very crucial. So if you talk in the sense of what should I say, in terms of statistics, in terms of machine learning, that this is the mean of your problem and so and so, so definitely they're not gonna understand your language, right? So if, when you are explaining to your client that this is the problem, and here you can solve this by this particular factor. So you should have a knowledge of how to make a story out of that and telling those person in a very layman language so that they can understand in a better way, and hence they can believe you and believe that your prediction, your insights are very good, correct? So this is again one of the thing which you should give a read. Like business analytics requires a combination of expertise across business, information, right, and mathematics, correct? Okay, so I hope this is clear with you, right? So what is data scientist and what are the different roles? So except these three skills, you definitely require storytelling, right? Okay, so let's move forward. All right, so now we have a different forms of um, analytics, right? What are the different forms of analytics? Okay, so let's cover one by one. Um, yeah, so let's start with descriptive analytics. So descriptive analytics, we have a descriptive analytics, we have a diagnostic analytics, we have a predictive analytics, and last we have a prescriptive analytics or analysis, right? One and the same thing. So now what is descriptive analytics? Descriptive analytics is, as it's written, insight into the past. What does that mean? Insight into the past means you should have a knowledge that what all happened in your history by looking at the data, right? You should have a knowledge that what all happened in your past. So that is called descriptive analytics. And what is diagnostic analysis? So getting deep into the history, that why the things has happened, that is called diagnostic analysis, right? Then third, we have a predictive analytics. So I feel this is very much clear because the name is very clear, predictive. So we are predicting the future, and this is something where we use statistical models, right? Statistical models, and right, and machine learning. We use here machine learning and statistical model to predict the future, right? Last one and very important, that is prescriptive analysis. So mostly people get confused between predictive and prescriptive. What is that? Okay, so let's get into prescriptive. So prescriptive is advice on possible outcomes. So what does this means, right? So it's a prescription. Let's say when you go to your doctor, right? If you have any problem, like you have a dengue, right? So you go to your doctor, he check the symptoms, or you tell them that I feel like I have a dengue, I have some sort of these symptoms. So he prescribes you a medicine, correct? So that is called prescriptions. He's prescribing you medicines so that the outcome is you get rid of that particular illness, that dengue, right? So again, here, if we talk about data science part, then this is the part where some possible outcomes, some possible solutions are given by data scientists, which can be opt as to solve that particular problem, correct? And we'll get into depth of all of these four, right? Very, very depth. Okay, so before getting into depth into this, we will have again a look over a quote, which is very, very important, which I think is a basic building block of data scientist. If you master this skill, then nothing is impossible. Okay, let's move to next slide. Yeah, so please give a read to this. Okay, okay, so let me explain. The scientist is not a person who gives the right answer, but the one who asks the right questions. So please concentrate on this part, right? So asking a right question is very, very important, believe me. So why? Because you have lot of data in your market, lot and lot of data. As per IBM, they said that in last 2 years, the generation of data is about 70 to 80%, right? 70 to 80% as compared to the previous years. If we comparing last 2 years with all the previous years, the generation of data is so huge, the velocity is so high that it is 70 to 80%. So we have lot and lot of data with us. But the thing is, asking a right question and then finding that solution is very, very important. So having a skill of maths, right, software engineering, and what next, business, is definitely very, very important. But at the same time, after mastering these skills, you should have a knowledge of asking a right question. So this is something which is called creativeness, right? And most of the time people ask me like, is data science gonna take jobs of other people, right? So this is again one of the very good question which people used to ask me. So no, please do not worry about that. So data science is something which is helping you to getting things done more easily and in a most fast manner. This is not something which is taking your job, correct? So because the reason of this is because definitely your machines are helping you to do things in very, very simpler ways, but your creativeness and your mind, your skills is required in this. Okay, I was writing, I don't know what is. Okay, so your creativeness and how to do the things, that is very, very required by a human being and a human brain, correct? And this is something which will not take job of anyone. So only a human can think and make machines work for them, right? Okay, so let me clear this. Okay, right. So let's get deep into different forms of analytics, correct? Okay. Huh. Right. So we were talking about data descriptive analytics. So what is descriptive analytics? It's a basically use of data aggregation and data mining to provide insights into the past, right? And what it actually tries to help you with, this is the main question. So the answer is what has happened in your history, correct? So this is the question which is solved by descriptive analysis, right? That what has happened in the past, okay? And where we can use, so I have given a case, use descriptive analysis when you need to understand an aggregate level what is going on in your company, and when you want to summarize and describe different aspects of your business. So this is somewhere we can use. But all in all, you can remember what is descriptive analytics analysis. This is something what has happened. It explains you that what has happened in the history of your company by using data. Correct. Now we'll move to diagnostic analysis. Okay. Uh, Diagnostic analysis is something. Oh, okay. Is something which is telling you use of data exploration techniques to dig deep into data, right? And what problems it solves is why has happened. So now we know like what has happened. Now we need to know why the things has happened. So that is called diagnostic analysis, right? And the case which I have given here is use diagnostic analysis when you need to understand at a deep level why things are going on in this manner in your company or for any specific client, right? For anyone, if you want to dig deep, so this is useful. Correct. Okay. So let's move to next, which is predictive analysis, right? Okay. So predictive analysis is something use of statistical models, as we discussed earlier, forecast techniques to understand the future basically. And what it tells you what could happen, in the future. This problem is solved by predictive analysis using statistical models and machine learnings, right? And this, please read this one also, like use prescriptive analysis anytime you need to know something about the future or fill in the information that you do not have. Correct. Okay, so let's move to next, prescriptive analysis. So prescriptive analysis is use of optimization and stimulation algorithms to advise on possible outcomes. So sometimes it becomes a bit difficult to understand things. So let's come to the point, which is what should we do? So this is the question which is solved by prescriptive analysis, that what all things we can prescribe for this particular problem. And use prescriptive analysis anytime you need to provide user with advice on what action to take. Correct. Very, very simple. Please do let me know if you are confused with any four of them, and I would be very, very happy to help you understand it better, make it more simpler if required for you. Correct. So I'm giving you 10 seconds, 5 10 seconds. Please do let me know if anyone has any you know an issue with understanding this. Okay, so this seems that things making sense to you, and that is very, very good. That is perfect. The starting is going very perfect. Okay, so let's move to next slide, a data science process. Okay, so what is a data science process, or a day of a data scientist? What all things he have to go through? What is the process? Okay, so let's start with this. Okay, so here we have a real world. So definitely problem comes from real world. And what is our first step? So this is our first step, right? And which is asking the right question. Asking the right question is very, very crucial, believe me, because it's not the thing that you'll get a pizza on in front of you and you have to start eating that, right? So the problem given by a client or your CEO or anyone, that is something like my sale is decreasing day by day, right? So please do something. Please find factors by which I can improve my sales, right? So if you give this statement, so this is something a business problem, right? You have to convert it into analytical terms, which is very, very much required. You have to be very, very specific to what all things you are looking for, right? and that is called asking the right question. Okay, so you can convert this situation, right, decreasing sale to like, what is the level of sale in last 3 months as compared to the previous 3 or 4 or 6 months. You can check that, right? What are the factors affecting that? So this is one of the way of solving this, correct? Okay, so let's move to next process. Next we have raw data collection. Okay, this one is better. Okay, so next one is raw data collected. So now we have the question with us, so we'll collect data, and data can be in very different form, believe me. It may be structured. I'll write it down. It may be structured. Okay, so it can be structured, it can be unstructured, and it can be semi-structured, right? SS, semi-structured, structured, semi-structured, and unstructured, right? Okay, so these are the three different forms, and we can extract data from SQL. So SQL is, structured query language. You get structured data from that, and other sources are there like web page, right? This is web page. You can extract data from web page, right? And after collecting raw data, then you have to make it, which is the third point, is data processing and cleaning. Okay, so you have to process that data, you have to clean it, correct? And cleaning is something which is done by your tool, correct? So here comes the work of your tool, and we are doing here R language, data science tool. So R is used to, process your data in many different forms, correct? And from here you can after processing and cleaning your data, right? I mean, the data is in raw form, right? So you have to make it somehow that you can read it, the machine can read it. That is called processing and cleaning the data, right? So there are a lot of what should I say, gaps, like where no data is present in the columns. Excuse me. Okay, so there are times when no data is present, and a lot of different situations when data is absent. You have to, or I mean, there are different lot of situations where data is not able to process, or not able to, you can do any exploration over that. So this is the thing where you can do data processing and cleaning. Okay, so this is the third point we have, and after this we have two options, right? If you do not want to explore the data, otherwise this is the fourth point, right? Exploring data means to knowing about the data, right? As this, icon or symbol lets you know, this symbol and then all those, what these symbols are telling you, that you're finding something from your data, right? Or you can say you are understanding your data much better. So remember one thing, understanding your data helps you to make your model very easy, right? The person who is having a good understanding. So again, if we um, take an example of real life, if you're having a good understanding in a relation, then you're better in that, right? So again, the same, if you have a good relation with your data, then it's very easy, believe me, to get insights from it, whatever you want. Okay, right. So if you want to explore your data more, although you have explored your data in data processing, some sort of exploration, right? Because before exploration you can't do the things if you do not know what things are lying where. So you can't process anything, correct? Okay, so if you need depth in exploration, so you can come to the fourth point, which is data exploration. If it's not required, then you can directly jump from this to here, which is called machine learning, or uh, yeah, or statistical modeling, right? Where the data got processed. Or if you need exploration, then you come to data exploration, right? Even after processing, and third, I'm talking about third step after doing data processing and cleaning, you're exploring it, let's say, right? But you're not able to explore because again there the data is not in formatted in better format. So what you can do, you can again make data your to backwards and again clean it more. So this is the back and forth process, right? And believe me, uh, this if you include second, what has happened? Okay, second process, this second process, third process, I'll tell you, second, third, and fourth, it will take around 70, not 70, I would say. Okay, so I mean near about 80% of your time to do data scientist or data analyzing process. It will take your 80% of time, 80 to 100 somewhat, right? 80 to 90, 80 to 100, correct? And the rest 20 or 10% is taken by your fifth process, which is machine learning, because we do have libraries which where you can take a function which is a predefined functions, correct? And you have to just put it on and the things will move very, very simple form. But this second, this third, and this fourth process takes your 80 to 90 or to almost 100% of your time to make things sorted out. Okay, so I feel this is clear. Like if your data have processed, then you can turn it into the exploration stage. Now if you cannot explore it because the data is yet not cleaned, not in a better format, then again you can make it back to the data process cleaning. So this is a back and forth process which take a lot of times. Okay, so after this, let's say you have explored your data, then you can come to machine learning, shift your data to machine learning. Now you will apply machine learning algorithms, statistical modelings to your data, correct? And there are a lot of different what should I say, modeling techniques, correct? Like we have linear regression. These are machine learning algorithms. We have logistic regression. Okay, then we have clustering, we have, right? And then we have classification. There are a lot of different methods. So it totally depends upon, and many people used to say like, what should I use? What should I learn? Which algorithm should I learn first? So see, this is totally depends upon what things you are solving, right? So it totally depends what thing you are solving. So different things have different algorithms used in different scenarios, correct? Yeah, so definitely this is something which is machine learning is itself is a very, very huge topic which we'll cover sometime later, correct? But here I have told you, given you idea, like these are some kind of machine learning algorithms. Okay, so next we turn to the sixth stage, which is this is the sixth stage, which is now your insights have been taken. Now you have to present it with the use of data reports and visualization, or if you're making some product out of your data. Yeah, definitely there are data products, right? Which are used as a product, and that is called data products, right? So it totally depends what kind of problem you're solving. Okay, and why this is used, because as I told you, so getting insight from data is one thing, and explaining to others in an easy format, in a layman terms, that is a different thing. So we use data visualization and reporting to solve this kind of issue. And again, the from where the problem have came, that is real world, the solution goes to again the real world, right? So this is the process. Hope this is making sense to you. Yeah. Yeah, please do let me know if there is any kind of issue in understanding any of the topic, or you want to have a get any depth into any one of them. Yeah. Okay. Perfect. Perfect. Okay, so let's move to the next slide, which is our uh, data analytical tools. Okay, so here we are doing let's choose the color. this one. Okay, so we have different tools, but I have given few which are very useful and used by industry. First is R, very useful. Then we have Tableau, then we have Python, we have SAS, we have Excel. So every tool has its own pros and cons, right? That's why these tools are required. Otherwise there must be a one tool which can be used by everything and each and everything, and okay. So we are concentrating on R specifically here, right? But we have different tools also. And let me tell you, R is an open source tool, right? And if we talk about Python, it's again open source. SAS is not an open source, right? Excel, if we talk about, so Excel is something where small amount of visualization basically is happens, right? And there are a lot of companies who are still using Excel because the data is not too much, right? So those data analysis can be done on Excel very easily. So why do take these R and SAS and Python and Tableau kind of languages, right? If things can be done with a simpler form, so why to take difficult languages, correct? Okay, so let's move to the next slide. So here we comes the example, the application of data science, right? So let's have a look of this pic, and what do you understand from this pic? Please do let me know. Okay, perfect, perfect. Okay, so so we use Gmail in our day-to-day life. So this is the example of Gmail only, right? So we apply, when we use Gmail, some emails come to our spam folder, which is bad emails. Some comes to our good emails, which comes to our inbox. So this is the difference. So this is called filtering, right? So this can be done using machine learning, correct? And this is called filtering. And we can use tool for this is R, Python, right? SAS, all kind of tools are here. So this is one of the example. So they apply a machine learning algorithm to choose a word from the mail, right? From the mail itself, that if this word exists in the mail, that this so this means that the mail is somewhat is a bad mail, right? Which is some advertisement or promotion, these kind of mail, right? So these kinds of mails are not required, so put it into bad emails or spam, correct? So this is one of the example of machine learning. Okay, and let's move to very good example. Next example is, which we are using. Here it comes. Okay, so this is Netflix. I feel most of us use Netflix to watch movies, correct? Okay, so what it shows is congratulations, movie we think you will add, correct? So we when we see any movie, uh, so the Netflix, what it does is it recommends you other movies. So this is called recommendation system, correct? So they are recommending you movies using a machine learning techniques, that if a person is liking okay, okay, so if a person is like any movie, particular movie, then he or she must be like these kinds of movie, right? So this is called recommendation engine, and again this can be done using machine learning with any of the tool, R, Python, SAS, or anyone else, correct? And this is an example of Facebook. When you add people as a friend, then Facebook will recommend you different kinds of people like this Harry. So he's recommending you Harry. You can add him as a friend. You can add Gina as a friend, right? So this is again a recommendation engine. So I mean, we are using recommendation engine in very different sites, in very different social platforms, correct? Okay, so this is an example of Twitter. So if you follow someone, so again, the Twitter recommendation engine starts recommending you different people, different people to follow. Like Sharpie, if you have you must have followed something, that's why it's showing you Sharpie, right? Twitter ads and Twitter small biz. So you can follow all this on the basis of your last following, correct? And here comes the YouTube, correct? Whenever you watch any particular video, so you must have seen the right side, there's recommendation, then you can watch this video, this video, this video, this one, this one, this one, right? On the basis of your list which you have seen. So they are recommending you. And again, recommendation system in itself is a very, this is not like it's a one kind of recommendation engine. So basically, if we talk about a bit about recommendation engines, uh, recommendation engines, or you call recommendation systems, correct? So they are basically divided into two type. First one is uh, a normal recommendation engine, right? So it will give you those items which are very popular or latest, right? Latest or popular basically to each and everyone, right? So popular things, right? And second one is which is called personalized. So what is personalized? So as the name suggests, like whatever you have done on that, on the basis of that history, it will recommend items, correct? On the basis of your history. Like if you talk about YouTube, right? If you talk about Netflix, Facebook, Twitter, right? So there are sometimes when people are very new. Let's say you have made your account just now, right? In um, in Netflix, or let's take example of YouTube, most because we use in daily life in many different ways YouTube, right? So you have made your new account in YouTube. So how could the YouTube know like what are your personalized things, because they do not have your data with them, right? So they'll start displaying you the popular ones, popular videos which are popular in your area, which is popular in your country, right? Very popular thing which most of the people are having a look. So popular thing. And once you are starting using that, so right, once you're starting using that, then on then the YouTube recommendation engine, which is second one, will give a personalized, right? Personal recommendations on your basis of your data collection, right? The data is generating whenever you're watching a video. So on that basis, the YouTube will start giving you recommendations, correct? So these are very good examples in day-to-day life which we are using, and there are a lot of different examples of data science, and lot would be coming in very coming days, coming years, you'll see. Yeah. Okay, let's move to the next slide. Okay, so here it comes the industries using data science. Yeah. So again, so there are a lot of different industries. If we talk about financial market, so this is something which is dependent upon core data. They are doing their things on the databases only. Then we have insurance, to whom we should give insurance, to whom not, right? These are some things which depend upon core data, right? And then we have retail banking, right? To whom we can approve the loan or debit card or some these kinds of things, right? So that is dependent upon your previous history and analyzing those history, right? So that's why they're using data science. Okay, so the next is e-commerce. So e-commerce, we all know, like Amazon, right? Amazon is and the related sites, Flipkart and all those, right? So these sites are whenever you see any product particularly, they'll start recommending you different product on the basis of your view of current product. Or if you're new, you have just opened a new window and you're not logged in, so they'll start giving you a uh, popular items in your current city or state, right? And as we have discussed, Netflix, YouTube, so the same example, right? Okay. And health industry, so health industry is something which is using data science in very different ways. and solving very, very big problems like cancers and all those things are solved by data scientists. And there are a lot of different things which is solved by healthcare sector. Okay, and then we have energy, we have web analytics, we have search engines, right? So web analytics is again as we have discussed, YouTube and what should I say, Netflix, right? Twitter, Facebook, these are on web analytics, right? And search engines, so we have a very, very good name, I think we all know, is Google. So he's using machine learning and data scientists in very, very different ways. The very first is like whenever you search, right? I'll give you a quick demo also. Yeah, okay. So like see, whenever you put, let's say, open a Google, you must have seen, a practical knowledge is much, much better. Just explanation. Okay, I am not working. Yeah, yeah, it's working, it's working. Okay, so whenever you put something, it will start suggesting you things. So this is because of machine learning. Let's say we put DA. So as we have put DA, so see, it has started suggesting different things: data science process, data science philosophy, Dangal, organic Bhaskar. So it on what basis they are suggesting me? They are suggesting me on the basis of what should I say? On the basis of
Hello.
so these are some industries which are using, and believe me, in a coming futures there would be many, many industries which will gonna use these data scientist things, because this is very, very helpful in each and every way. I mean, yeah. Okay, let's move it. Okay, so let's talk about the companies. Yeah, so this is a we should have a good knowledge of like who all companies are using R as a data science tool, and hence we can work over the same. So again, R, Facebook is something um, who is using different techniques to solve data science things. I think there is a message from someone. Let's check if someone is having any issues. No, okay, fine, things are going very, very perfect. Yeah, cool. Okay, so yeah, so Facebook is someone who is using R as a tool to solve data science problems, right? And they're very well known companies. Google is there, eBay is there, right? Bank of America is there, right? So Ford is there, and Cardio DX is there. A lot of different companies are using, and why they are using we'll cover in the very next chapter, intro to R language, that why they are using, what are the factors which make them derive to use this particular tool. Correct? Fine. Okay, so let's move. Right, so now it comes to the big data. Oh, big data is something which is very, very new, um, and in last few years the name has arrived, and it's a very buzzword, as I told you. And let's dig deep into what exactly it is, right? Okay, so have a look over the picture and just try to understand, then I'll explain each and everything. Correct? Take your time, just for 5-10 seconds, and make it clear like what are the things here. Give a read. Yeah. Yeah. Okay. Perfect. Right. So let's start. So yeah, big data is again. So don't make it things very, very complicated. Big data is nothing but it depends upon three V's basically, right? Three V's. but I have mentioned here 5 different V's, right? So to make things more clearer, more better, right? So I have mentioned 5 V's, otherwise 3 V's are more than enough to understand big data, and that is volume, we have velocity, we have veracity, right? Sorry, I make variety. Yeah, volume, velocity, and variety. These are the 3 things which can, simply explain big data. But I have added 2 more points, that is veracity as well as value, right? So these 2 points are included. Okay, so let's get into this, right? Yeah. So big data. So what do you mean by volume? So volume is the size of data, right? So like as I told you, like as per IBM in last 2 years, the volume, the data is generating very high amount. We have lot of data generating through different platforms, web, Facebook, Google. I mean, don't know in a minute how much amount of data getting generated. There are a lot of different lot of volume of data is, I mean, very high, right? And then we have velocity. Velocity is the rate of data generation, the speed, right? So again, the speed is very high. So as I was saying, IBM as last 2 years, 70 to 80% of data was generated in last 2 years as compared to previous years, right? And then we come variety again. So I have discussed this point earlier also. So let's discuss it one more time. Different types of data. So what is the type? I have told you there are 3 types. That is structured, right? Okay, let's try to write it. Let's try it. Structured, okay. Uh, structured. Okay, so we have structured data, we have unstructured data, right? And we have semi-structured data, right? Okay, so concentrate on this part, right? So we have structured data, we have unstructured data, right? And we have semi-structured data, right? These are the 3 forms. One is this, second one is this, and third one is this, right? Structured, semi-structured, unstructured, right? And mostly what you'll find is the data is in unstructured or semi-structured form, right? And that's why that is called raw data, and to cleaning it, processing it, that takes a lot more time, 80 to 100% of time, as we have discussed in earlier slides, right? So this is the thing. Okay, and let's get yeah, so this is the variety part. Now the veracity, so the accuracy, because your prediction is totally depending upon that data, right? And if that data is not accurate, then how can you assume like your prediction is correct, right? So accuracy is very important. That is called veracity, trustworthiness of your data, right? You can see here, yeah, here, trustworthiness, right? Okay, and the last and the 5th point is value. So what value you give from your data? Here you can read, just having big data is of no use unless we can turn it into value. So turning it into value is again very important. So that what we have learned in data analysis or data scientist part, right? So getting a data is different thing, getting insight from that, value from that data is different thing, and explaining to your client is again a different thing. So getting value is very much required in, again, big data also. Okay, and you can have a look, you can read these lines, which is big data is about analysis, okay, for data that is really messy, because it's a large amount, and definitely it's a messy, unstructured and semi-structured data, or whether you don't know the right questions, right? So this is the thing, yeah. So here it comes. See, I have given you a quote. If you don't know the right questions, this is very much required, or queries to make, analysis that can help you find patterns. So what we are finding patterns, right? We are finding insights from the data, right? So if you do not have a right question, right query, how can you find insights? Because we have a lot amount of data. What you need to do now is throwing a right question or a right query, right? Here it comes. Yeah. Okay. And anomalies or new structures. Uh, yeah. Okay. New structures, MDIST, otherwise chaotic or complex data points, right? Okay. So that's what we have learned. Like what is yeah, what is big data, right? What are its importance, right? So we have seen that, you know, it's a messy data. Yeah, so importance is like, you know, because the data is very in lot of amount, so you can get a lot more details from that at the same time, but it's raw and in a messy form, so you have to be caution for that. And we do have tools, so technologies which we use to handle big data are like Hadoop. You must have heard this name, or if you are new to this, you are introducing, I'm introducing it to you today itself, Hadoop, right? Hadoop, then we have Spark and other such tools which make our lives get easy to get insights from tons and tons of data, right? So these are some tools. So basically what the tool does is, I'll give you a brief view. What the tool does is, they are not, you know, what they does is they are just making your, because it's a very huge amount of data, so how can you store it, right? And how will you get it? Because getting and storing is something, a challenge, right, in big data side. So these tools help you to store in distributed forms and taking that data when required, doing analysis over that data. So this is something which is done by Hadoop and Spark. So Hadoop is a base, and over that Spark is used. Even though you are using Spark, Hadoop is very much required at the same time. But if you're using Hadoop, then Spark is not required, right? But current market, Spark is very much needed. And again, so Hadoop is something a base, right? Hadoop is something a base. Okay. Okay. So here it comes. Let's move to the next. Okay. So whatever we have studied. So let's do a sum up, because it's very new things to you. So hopefully doing sum up is very much required, like doing revisions in your exams, right? So at the same time, in the same way, sum up is very much required. So let's sum up the data science foundation. Okay, so I'll read for you and I'll explain one more time whatever is written here, so that it will become very easy for you to get things in an easier form. Okay. 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 So let's get started without wasting any time. So what is data science? So data science is the study of mathematics, as we know, statistics, information, and domain knowledge. So again, maths and statistics come into one column, correct? And information system is again something software engineering, and domain knowledge is business knowledge. So which results in data-driven productive insights, correct? This is clear. If you have any kind of trouble in understanding this or any kind of issue, please do let me know. I would say I'm very happy to help you sort out your issues, right? But I feel things are going very fine. Let me check. Please confirm me once, like the thing, if the things are clear to you, or if you have any doubt.
Yeah, clear.
Clear?
Clear, Shahid.
Clear. Okay, fine, great. Perfect. So let's move forward. Okay. So we have completed first point. Now come to the second point. So second point is data analytics has four major forms. So we have discussed this earlier: descriptive, diagnostic, predictive, and prescriptive, right? These are the only four forms which we have discussed. Now we'll get into what are the four different forms, right? One by one. Here it comes: descriptive analysis. So please keep reading these words, because that makes easy for you to understand also, right? So descriptive analysis or statistics does exactly what the name implies. It describes or summarize raw data and make it something that is interpretable by humans, right? So it is just finding what has happened in the past. This is the thing which is solved by descriptive analytics, right? Okay, so let's come to the fourth point, which is diagnostic analysis. this is something which solves the why part of analysis by getting more sense of data insights, right? So again, so what part this diagnostic analysis is solving? I've told you earlier, it's why part, why the things have happened in the past, okay? And then we have a predictive analysis, right? So what predictive analysis do is it has its roots in the ability, okay, so predictive analysis has its root in the ability to predict. So what is that doing is predicting. So name suggests very much clear what might happen with actionable insights based on data and provide estimates about the likelihood of future outcomes. Yeah, so using machine algorithms and statistical analysis using different tools, R, Python, SAS will do predictive analysis, right? Okay, and last part is prescriptive analysis, which allow user to prescribe a number of different possible actions to and guide them towards a solution. So okay, so you must remember we have taken example of doctor, right? A doctor example, because I've seen lot of times like people get confused because these are the questions which gonna ask in interview, right? Whenever you say them whatever you whenever you go to your interview, you must have write in your resumes that you have attended such and such course, or you have a good knowledge of data science and or R. So the interviewer will gonna ask these kinds of questions only, like what is predictive analysis, what is prescriptive analysis, because a newbie or a person who do not have a good knowledge or who has learned just now, they are not gonna convey that what these things are. So always remember what I was trying to saying is always remember the doctor example, right? Yeah, so doctor example is that difference between prescriptive and predictive. So I feel predictive is very much clear, predicting about future, right, using machine learning and statistics techniques, right? And prescriptive analysis is something prescribing, like giving solutions to the problem, that this kind of solution, or you can say these four kinds of solution can be applied on our problem to solve the issue, right? So like doctor is giving us medicines to solve our illness, our dengue, right? So this is prescriptive analysis. I hope it's very clear, and if it's not, please do let me know. I would more than happy to help you. Okay. Okay, so few points are left out. Okay, so let's cover them very quickly. Um, okay, so initiating. Okay, so this is what this is the we are discussing a data science process, right? So what is data science process? Initiating with framing the problem, right? So the question came by CEO or client is in a very different form. So